Welcome to Train Signal. You're watching a video about TCP/IP protocols. Now, in this video, I'm going to cut you a little break. I worked you pretty hard in the last video, so we're going to reel it back just a little bit and just simply go over a list of various protocols. Now, speaking of that last video, you may recall that when we were going over the TCP/IP architecture, that I had mentioned that the application layer contained a number of protocols that we would come back to later. Well, many of them we're going to cover right now. So, let's go ahead and get started, and like I said, we're just going to go right down this list and cover all these various protocols. The first one is FTP, which stands for the File Transfer Protocol. Now, the File Transfer Protocol provides connection-oriented file transfer between a client and a server. So basically, the File Transfer Protocol is exactly what it sounds like. It's used to transfer files between computers. Now, I will re-mention the fact that it's connection-oriented file transfer, which means it utilizes the TCP transport layer protocol. And you'll notice here that I've also mentioned that FTP uses TCP port 21 for control and TCP port 20 for data transport. And that's something you will want to know. You'll want to know that FTP uses ports 20 and 21. Now, the reason I emphasized the connection-oriented aspect and the fact that it uses TCP is because here we have TFTP, which is the trivial file transfer protocol, and you'll notice here this provides connectionless file transfer functions. Okay, so this is obviously going to use the UDP transport layer protocol for connectionless communication. Now, TFTP is a very simple, very small protocol, making it very suitable for transferring small amounts of data. Okay, thus the name trivial, meaning kind of insignificant, small amounts of data. Now, it is primarily used for things like updating network devices, which we'll talk about later, things like routers and switches and stuff like that. But it also is sometimes used for the transferring of data needed to boot a diskless system over a network. There are some computers that do not have hard drives in them. There are computers that can be booted remotely across the network by simply sending a couple of really small pieces of data to wake up the computer via the network card. Okay, and that's another use for the trivial file transfer protocol. Now, I mentioned that it's connectionless, meaning it uses UDP, and sure enough here, TFTP uses UDP port 69. Okay, so TFTP 69. Next, we have what's probably the most, or what could be the most familiar protocol to you, it is to most people, which is HTTP, which stands for the Hypertext Transfer Protocol. And you see here, it was originally designed for transferring World Wide Web documents, but it has also been extended to transfer other types of files as well. So even though we primarily know HTTP as being used for accessing websites, right? I mean, its most common use is for clients opening up a web browser and accessing a website off of a web server. HTTP has also been extended to do other types of file transfer. As a matter of fact, in some ways, the newer versions of HTTP can be better for transferring files than FTP. So keep in the back of your mind that HTTP is not exclusively for accessing web pages, but that is what it is primarily for. Now, HTTP uses TCP port 80 by default. And the reason I say by default is because that port number can be changed. When you are in a web browser, you can put a colon and then a port number after you enter in the website address you're trying to get to, and that would still allow communication between the web browser and the web server via HTTP, but it would no longer be using port 80, it would be using whatever that port number was that you keyed in. But primarily all you need to know is that HTTP is port 80. Next we have HTTP TCP/S, which essentially is the exact same thing as HTTP, except for that it uses SSL, which stands for Secure Sockets Layer, to send data in an encrypted form and to authenticate the server. And the best example of where you will see HTTPS used is if you are buying something online, so via a website, using personal information like a credit card. When you do this, it needs to be done securely, and HTTP all by itself is going to send all that information across the World Wide Web in plain text. And that's not a good idea when it comes to private information like your credit card or your social security number, things like that. Whereas with SSL, there's two functions. One, we get to authenticate the server, which means you get to verify, as a client, you get to verify what server it is that you are communicating with. That way, you're not just on some web page that says, okay, you want to buy this product, give me your credit card, and you may not realize, but you now are on somebody else's web page. So now you are actually authenticating the web server, but also to encrypt the actual data as it transmits across the World Wide Web. Now, HTTPS uses TCP port 443, again by default, because that can be changed, but basically all you need to know is HTTPS port 443. Next, we have NTP, which stands for the Network Time Protocol. And the Network Time Protocol is used to, well, provide time synchronization. Now, computers will synchronize against a certain time source, which could be an NTP server, which could either be within a local network or could be out on the internet, or can also be done, believe it or not, via radio or satellite receiver. Now, NTP is very accurate and it's capable of synchronizing distributed clocks to the nearest millisecond. Okay, and many of today's networks, and to be more specific, today's network operating systems require that the clocks within your network be in sync with one another for things to function properly. And this has a lot to do with replication of information between different servers and different computers around the network. That's why it's so important to have accurate time these days. Now, NTP uses UDP port 123. So 123 is what is used by NTP. Next, we move into, I have a couple of protocols here, and the reason I have these together is because, well, they serve a very similar purpose. Both POP3 and IMAP4 are used to retrieve email. But POP3 can only be used to access the inbox folder from your email server, whereas IMAP4 can be used to access all server-based messaging folders. And here's the thing, with POP3, if you're going to use what's called a POP3 mail client, well, if you want to have any organization of your data, you're going to have local folders within your client where you move the mail to. Whereas with IMAP4, because you can access all the different folders, you can create an organizational hierarchy of folders and keep that out on the server, but manage it from the client. Now, a couple of ports you need to remember here. POP3 uses TCP port 110, and IMAP4 uses TCP port 143. Now, if we're going to talk about email client protocols, I guess we should talk about email server protocols, and that would be right here, SMTP, the Simple Mail Transfer Protocol. It's real simple. This protocol is used for sending email to and between email servers. Okay, so it means it's used for sending email to an email server and then also between email servers. Okay, a lot of people from the client standpoint will think of POP3 or IMAP4 as your inbound mail and SMTP as your outbound mail. And the reason is because when we say outbound from a client, where's it going? It's going outbound to an email server. And then from your email server, it then gets transferred to another email server. And so that's where SMTP is used. Now, the only other thing really to remember about SMTP is that it uses TCP port 25. Next, we have DHCP. Now, we've talked a little bit about DHCP already, and this stands for the Dynamic Host Configuration Protocol, and it's used for assigning dynamic IP addresses to devices on a network. Now, DHCP, as we've learned before, simplifies network administration by keeping track of the IP addresses in a database rather than an administrator having to manage and then also assign them manually. I mean, that's the bottom line. DHCP makes it that IP addresses can be assigned, assigned and managed dynamically. Okay? It gets rid of all the manual aspect of assigning IP addresses. Now, DHCP uses UDP ports 67 and 68. And I'm going to tell you where that comes in most handy as far as knowing those port numbers. And that is that we'll learn later on that routers don't allow broadcasts to pass through them. Okay, that's something we'll learn actually in the next video when we talk about some of these networking devices. So routers don't let broadcasts pass through them. Well, I can also tell you that DHCP uses broadcast transmissions. Thus the UDP, it's connectionless transmissions, it uses broadcast transmissions. So if you have a DHCP server on one side of a router and DHCP clients looking to get their IP addresses on the other side of a router, well, the communication's not going to pass through that router unless you enable those DHCP broadcasts on the router. Now, some of today's routers allow this. Matter of fact, most of today's routers allow this. And the way you enable it is by opening up UDP port 67 and 68 and telling the router, I want you to pass these broadcasts through. That is the most common place where you will need to know those ports when it comes to DHCP. Next, we have DNS, which stands for the Domain Naming System, which is a standard name service that allows your computer to register and resolve domain names, or what are sometimes called host names. So pretty much the way to simplify it is DNS provides for what's called name resolution. It's what allows us, as I like to call stupid humans, to be able to access computers, or we could even say out on the internet, access websites using names. Because it's easy for us to remember names, but not easy for us to remember long IP addresses. Okay, if you want to go ahead and go to trainsignal.com's website, well, you don't want to have to remember the IP address. You don't want to have to remember some number, dot some number, dot some number, dot some number. That's not easy to memorize. But if you know that the name of the company is TrainSignal, it's pretty easy to remember that our website is trainsignal.com. Well, DNS is what allows you to enter in trainsignal.com and then convert that to an IP address and truly communicate with the web server. DNS uses both TCP and UDP port 53. Okay, so the one main thing I want you to remember when it comes to port numbers is that DNS uses port 53. But to be more specific, if you want to break it down, DNS will use TCP port 53 for what's called zone transfers, and that's where you're transferring the information that's in a DNS database. A DNS server will have a database of names and IP addresses. Well, if you're going to transfer that database from one DNS server to another, that uses TCP port 53. Whereas when a lookup is done, the lookup from a client to the server is done on UDP port 53. Next, we have Telnet. Telnet is a terminal emulation protocol that allows remote access, and not just remote access, but remote access and management to a system. Now, the name Telnet can also refer to software. Telnet is the name of the software that the client will use when making a Telnet protocol connection to remotely configure operating systems and network devices. Now, Telnet uses TCP port 23. Now, Telnet is quickly becoming somewhat a thing of the past. I mean, it'll hang around for quite some time, but on a large scale, it's becoming a thing of the past. And the reason why is because Telnet is not secure. Okay, all Telnet communication is done in what's called plain text or clear text. And so that can be dangerous, especially when you are logging in and giving a username or password. So we have the introduction of SSH, which stands for Secure Shell. And Secure Shell can be used to provide very similar functionality as Telnet, but it's going to be more secure. And the reason why is because SSH employs encryption through certificates and then authenticates the server to the client. So it's kind of a lot like, the easy way to think of it is, Telnet is to HTTP as SSH is to HTTPS. It's kind of like saying we're adding SSL to it. We're adding encryption to it. Now, I don't want you to get confused and worried about this thing called certificates, but certificates are what are used for encryption and authentication. So SSH will provide that. Now, SSH operates on TCP port 22. This moves us into SNMP, which stands for the Simple Network Management Protocol. And it's used, this will sound like a surprise, for network management. Kind of like the simple mail transfer is for mail transfer and file transfer is for file transfer. Well, again, a lot of these are named very appropriately. And the Simple Network Management Protocol, or SNMP, is used for network management. Now, SNMP works by having various network devices, such as hubs and switches and routers and, well, even computers, acting as what's called agents, SNMP agents. And they collect information about themselves and communication on the network. And then that information can then be provided to what's called SNMP managers. You can get SNMP management software, which is designed to gather this information so as to figure out what is going on your network with all your networking devices to help you manage it. Now, I will tell you that there's a lot to know about SNMP. You will hear things like MIBs, and no, we're not talking about the Men in Black, for if you are a fan of that movie, but no, they're message information blocks, and that's really what the agents collect. And you'll hear about SNMP communities, because the community is what is used to determine which agents will communicate with which managers. But I don't really want you to worry too much about that right now. What you need to know right now is kind of what SNMP is and what its basic functionality is. And then if you end up in an environment where you really need to know about SNMP, go ahead and read up on the specific details. But I will also tell you that the other factor involved here is that each SNMP management software is a little bit different than each other. So the reality is you're going to want to learn it based upon the specific software that you are using. Now, the last thing I will tell you about SNMP is that it uses UDP port 161. Next, we have a couple of protocols which both primarily work with voice over IP. The first one is SIP, which is the Session Initiation Protocol, which is used to establish, modify, and terminate multimedia sessions. Now, some of the examples of these sessions might be different multimedia conferences or distant learning, or of course, internet telephony, which is what you think of when you think of voice over IP. You think of internet telephone. But all of this really is all a part of voice over IP technology. So the Session Initiation Protocol is used to establish, modify, and terminate the sessions, whereas RTP, the real-time transport protocol, provides end-to-end network transport functions which are suitable for applications transmitting real-time data, such as, again, audio, video, or simulation data over multicast or unicast network services. So kind of the easy way of thinking about it is SIP is used to establish, modify, and terminate the sessions, and RTP is used for the actual transport of the data. Next, we have TLS, which is Transport Layer Security, which is a protocol which is used for establishing a secure connection between a client and a server. TLS is capable of authenticating both the client and the server, creating an encrypted connection between the two. Now, when I mention authenticating both client and server, this is what's referred to as mutual authentication, where both the client and the server have to prove each other to each other. And this is done with TLS, and you'll notice here TLS is considered to be a replacement for SSL. Now, we're still, I think, quite a ways away from it being a complete replacement, but basically you can think of TLS as being a more advanced, more capable version of SSL, meaning it's used for authentication and encryption of communication between two computers. All right, well, that's pretty much all the protocols that we're going to cover for right now, and after watching this video, you should now be able to describe what some of the various TCP/IP protocols are and when they would be used. You should also be able to list the commonly used TCP and UDP ports. Now, you may have noticed that not every single protocol that we talked about had port numbers listed with it. I only listed the ones that are commonly referenced both on the Network Plus certification exam and then also referenced on a fairly regular basis in real life as a network administrator. So, that's all I got for you in this one. I look forward to seeing you in the next video.